As you view the screen here, I'm kind of hoping that you're wondering what these things are. So you're probably looking at here and going, okay, planes, what's that? Well, let's see if we can address that. Planes are a really useful way of describing movement, okay? And I want you to realize, first of all, each of these little kind of mannequin folk, and we're going to replace them with performers in a little, I'm not sure what I meant to say movement. We're going to replace them with real performers in a second. Each of these is standing in what we'd call an anatomical standing position. Now, we don't really study this on this course, but it's a nice thing just as a little addition to be aware of. You see, it's the palms facing forwards. The ankles are just sort of slightly flexed outwards and so on, and we're in kind of a neutral position. We call this the anatomical standing position. And once we sort of start to describe movement away from that anatomical standing position, we can describe that movement by which plane that movement is occurring along. So let's get sort of into this by looking at an example. This here is what we refer to as the sagittal plane. Now notice, single G, double T. I cannot tell you how many times I've corrected that in students' writing. Please try and get it right if you can. Single G, double T. Now the sagittal plane is really interesting because as I said a moment ago, movements occur along planes. So therefore, what kind of movement is occurring along a sagittal plane? Well, imagine, for example, that this elbow here was to flex and the hand was to come into that position. Or we were raising a dumbbell and it came here. Or if we really flexed it a lot and it came here. That would be movement along the sagittal plane. So we've got things like flexion. By definition, then it must be extension as well, right? Because if we were to extend that elbow back, let me choose a reasonable colour, back to here, but extend it back. Therefore, we're going to get movement along that sagittal plane through extension. Now, a couple of other examples. Imagine, for example, these toes were to point downwards here. That would, of course, what we would refer to as plantar flexion. Plantar flexion, two words, of course. That plantar flexion is movement along the sagittal plane. And because, of course, we've got plantar flexion by definition, we also have our single word dorsiflexion along that same plane. So start to think about actions and sporting techniques that would occur along or predominantly occur along this plane. Well, I'd like to address for you that running, obviously a central feature of so many sporting activities, running happens along the sagittal plane. When this knee moves into this position, what we would call, of course, flexed, or when the hip moves to here, in an extended position, those are happening along that sagittal plane. So we've got running. We've also got actions, and I'll show you a bit more detail of this in a second, such as somersaulting. Imagine if this person was to rotate all the way around here in a forward roll, somersaulting, back somersaulting in the opposite direction, of course. Those will be examples of movements along the sagittal plane. I also like the example of kicking. I think kicking is a really nice one, whether that's a penalty in rugby or some kind of football experience. We've got kicking as well. Now, let's move it forward. What we have here is the frontal plane. Okay, so nice simple word, frontal plane. Now notice this time, plane, which is exactly the same structure, is sort of moving across the whole of the body from shoulder to shoulder, from hip to hip, from ankle to ankle, rather than sort of through the mid-splice of the body, which is what the sagittal does. Now, kind of actions that we would be expecting here, we'd be expecting things such as abduction to occur along this plane. How do we know that? Because if the shoulder was to abduct here, or here, or here, or here, you can actually see that that is along that plane. If they were to move back towards the midline, of course, they would be examples of adduction. Okay, so abduction, adduction. Now, types of examples of sporting movement. You're probably going to tell me things like a star jump. You might say, James, what about a cartwheel? That's the classic example, right? Absolutely. Cartwheel's a lovely one. But the other one I really like to read students to write down, or have students write down, is the idea of something like a diving save for a goalkeeper, maybe in hockey. Something like a diving save. Imagine this goalkeeper, this character sort of flings themselves this way, their arms abduct at the shoulder, and they save or tip a ball over in the top corner of a goal, something like that. That will be movement along that frontal plane. I really think that's a nice example. Now finally we've got this one, and it's by far the most complex. This is what we call the transverse plane. Now I've said it's complex, I probably shouldn't have really, but let's see if it actually is. Where the transverse plane occurs it helps us to describe movements such as rotation. So if this character here was to kind of rotate around in this direction, or vice versa, I've sort of said it there in a clockwise direction, but it could be in an anti-clockwise direction, that would be an example of rotation. Now, rotation happens along that transverse plane, but it's not just rotation. Imagine that this person kind of lifted their arm to here and they had like a clenched fist, and they did sort of a hook shot in boxing. This is what we would call, of course, horizontal flexion. So movements like horizontal flexion, let's say throwing a hook in boxing, but they've also got horizontal extension, drawing that arm back. Those would be along the transverse plane. And the reason that is that this transverse plane can sort of be further up the body or further down the body, okay? It can actually be further up or further down. So there are three base planes that help us describe movement and what movement occurs along. Now, I've put some really high quality images in here just to emphasize those points or bring them to fruition. The first one is effectively you've got a somersault here. So here's the somersault example. We've already said this is along the sagittal plane. Now notice here, this leg is literally moving along that plane. This leg, this arm, even the head is sort of split along that plane. Now, just to be clear, if this athlete moved her arm out here, that would be a different plane, right? That would actually be movement along the frontal plane, and we do get movements which are combined. We've also got our cartwheel example up here, and we've got a really nice version of it here, I think. And notice here that this action here is the movement along in gymnastics of a cartwheel along the frontal plane. That's a really nice one. And this is actually my favourite one here. We've got the notion of a transverse plane. Of course, what we've got here is a spin, and we're spinning in this case in relation to a discus throw. But notice what it says, rotating in the circle only when spinning. Because if you notice, guys, if we bring the arm out here and here, this actual action itself, just holding them that way, that's along the frontal plane. It's abduction of the shoulder. But it's the rotating that we're interested in. The rotating is movement on the transverse plane, the spinning itself, only the spin, and that's really the intuition I want to draw you to at the end. Yes, we teach you sagittal, frontal, transverse, but please, as sports scientists, realise that these happen in almost all sporting movements in a combination type factor, sometimes explicitly so. Hope that's helpful. Thanks.